Today we're going to talk about proving angles congruent. We started off in class talking about this quilting example about why you'd need to know some angle measurements, and today we're just going to look at being able to prove those. Before we get started, let's talk about a term that I've actually used before. I've said this word theorem. And what that is it's a conjecture or a statement that you prove true. Now, once you've proven a theorem, you can use it all the time. After that, you just name it a particular theorem, and it's kind of like a shortcut of not having to do 5 steps. You're going to jump right in and just say, oh yeah, that's true because of this theorem that I've got. Now we're going to continue with our 2-column proofs here. Some of the reasons that we use for proofs now, as we've done a few of these, we can use given information. Sometimes they tell us some stuff up front. We can use definitions, we can use properties, postulates, and now theorems also. So here's one that, again, we've kind of alluded to this previously, but we're going to make it official here. And this is the vertical angle theorem, and it says that vertical angles are congruent. You might want to highlight this, do something in your notes. This is a biggie right here. We're going to use this all the time. Recognizing that when you have vertical angles like this 2 and 4, or maybe this 1 and 3, that those angles will always be congruent. That's a handy theorem to have. Here is the proof of it. If I'm going to call it a theorem, then I can prove it. If you'll recall that we have postulates. Postulates are something that we accept without proof, and we don't have very many things that we accept without proof. So most of our rules that we use are going to be theorems, not postulates. So I just told you that vertical angles are congruent there, but I'm going to prove it to you. So here's how this works. I have these 2 angles, 1 and 3. They're going to be vertical angles. I know that just because of the definition. It just is that they're across from each other from these intersecting lines. Now, I'm going to throw in this extra angle 2 here and use that as kind of a go-between with these 2 angles. 1 and 2 are supplementary, and I also have 2 and 3 supplementary. And you can tell that from the picture because they form a linear pair, and we have previously stated that linear pairs are supplementary angles. So we're using that. That's actually called the linear pair postulate. We've used that previously. And then I'm going to come back and say, oh, well, if 1 and 2 are supplementary, then I can add them and they're going to equal 180. And same thing with the 2 and 3. I can add them and they equal 180. Because that's what supplementary means. It means they add up to 180. Now they got fancy here on me. And they wrote this all out, but this is really just the definition of supplementary. Usually we just write definition supplementary. Okay, so let's keep going. Now what it looks like, now if you notice that 1 plus 2 is equal to 180, and 180 is equal to 2 plus 3, that's a quick, if they both are going to be equal to that 180 is kind of my go-between, and I could just say that measure of angle 1 plus 2 would equal the measure of angle 2 plus 3. And that's your transitive property. That's kind of like the if A equals B and B equals C, then A equals C. That's what we're doing right there. Now the 2's are highlighted in red here because what I'm going to do is, if both sides have a measure of angle 2, I'm going to get rid of it. And since it's being added, I'm going to subtract the measure of angle 2 from both sides, and then I'm left right here. Measure of angle 1 equals measure of angle 3, and if their measures are equal, we can say they're congruent. That's it's really like the definition of what congruent means. And so there we have a proof. Boom, there it is. Now we don't have to do this every time because we just proved that vertical angles are congruent. In the future, I'm just going to say, hey, I got this vertical angle theorem that says these angles are congruent. And I'm going to jump from, these are vertical angles, to, then they're congruent. And I'm just going to write vertical angles are congruent right here because I've got the proof of it here. Now I'm going to use my shortcut. All right, so using this is probably the algebra part that you're used to doing. And again, vertical angles congruent is one of the biggies that we're going to use all through geometry. If I have these 2 vertical angles, 3x and this 2x plus 40, I know that they are going to be equal to each other. So it's kind of like when we've been doing some algebra on some previous problems. and let's set things equal to 180, or if it's a midpoint, we set them equal. Same deal. Now we just have a new theorem that we can use to work through our algebra. All right, now the trickier part is doing the proofs and using that. So now I'm going to have that vertical angle theorem as fair game for one of my reasons over here. So let's start off with, what do we have here? We've got angle 1 and angle 4 are congruent. That's given to me. All right, those two are going to be congruent. Usually I like to mark my picture with any congruences that they give me or that I know. So I know that angle is congruent to this angle. What I'm trying to prove is that angle 2 is congruent to angle 3, that these two would have to be congruent. All right, well, let's work through it. Let's see. Start off, angle 1 congruent to angle 4. That was given. So we start off with just given information. Then it comes back and it says angle 4 is congruent to angle 2. Well, look at your picture. What relationship are 4 and 2? They're vertical angles. And now we know that vertical angles, and this is how I abbreviate it, just vertical angles congruent. That's a congruence on there. All right. And then they've got this all colored up for us so that you're supposed to notice some things. If you can see that, oh, if 1's congruent to 4 and 4's congruent to 2, then 1 and 2 are going to have to be congruent. That's the transitive property. Did you remember that one? All right, let's keep going. 1 is congruent to 3. Got a new color here, so I'm going to go back to my picture and see what's going on. Angle 1 and 3. Oh, 1 and 3. What kind of angles are those? Those are vertical angles. And what do we now know about vertical angles? Vertical angles are congruent. Got it again. All right, so now, looking at these previous steps, anytime you're going to your next step, you're either pulling from the picture or you're pulling from the previous step. And if you look at this, 1 and 2 are the same, 1 and 3 are the same, so they're trying to tell me 2 and 3 are the same. That's the whole, if A equals B and B equals C, then A equals C. That's your transitive property again. All right, and there's your two-column proof for that. Now, we are going to start getting into doing a lot of proofs, and so we keep getting these new theorems or postulates or definitions or whatever it is. So today it's lots of theorems. I'm not going to use them all today, but they're fair game now for us to use. This one's called the congruent supplements theorem. I wouldn't say we use this one all the time. It's not like vertical angles congruent, but it'll get used, you know, when you're talking about supplementary angles and stuff. This is one that should be popping up in the back of your mind. It says if two angles are supplements of the same angle. So over here you can see that it says 1 and 3 are supplements, and it tells me 2 and 3 are supplements. So what this theorem says is that if two angles are supplements of the same angle, so I'm talking about 1 and 2, they are both supplements of angle 3. Then those two angles are going to be congruent. Okay, well that would make sense because I know these two have to add up to 180 and these two have to add up to 180. Those are going to have to be the same thing. All right, so what you would know, what you'd be given is this information right here, and then you would come back and be able to say, oh, well then 1 and 2 are congruent because of the congruent supplements theorem. Now here's one that you can highlight and circle and put a big star on because we do use this one a lot, just like we do the vertical angles are congruent. It says all right angles are congruent. What that means is that if you know that you have some right angles, right here, angle 1 and 2, these are right angles, that's what I know, that's what's given to me, then I get to say those two would have to be congruent. So maybe I'm not really care about the fact that they're 90. What I really care about is that they're congruent to one another. So if I know this, my next step could be that they're congruent, and my reason would be all right angles are congruent. Now here's another theorem. Now I'm not proving all of these theorems to you. They could all be proven. We're just not going to go through the work of proving every theorem we come across. Now, this one says if two angles are congruent and supplementary, then each is a right angle. All right, so here's where you're going to see this. You're going to know that angle 1 and 2 are congruent. See how it's marked? And we also will happen to know that they're going to be supplements of one another. Well, the only way they can be identical measures and still add up to 180 would be if they are both right angles, if they're both 90s. Okay, again, we use it not quite as often as the others. All right, so just as a clarification, how is a theorem different than a postulate? Remember what I said, that a theorem can be proven. And again, I proved the vertical angle theorem to you. All of the theorems that we have in our book can be proven. A postulate is something we accept without proof. Now, that's all well and good. Remember, though, that ultimately what matters is that these are going to be reasons that you can use in your proof. Theorems or postulates, among others, definitions given, and other things that we can use. All reasons to use in a proof. All right, hope this helps. Good luck.